Sarab Sethi leads the interdisciplinary ecosystem sensing group in the Department of Life Sciences at Imperial College London, and is also part of Imperial X, an initiative that explores how AI can be harnessed to solve scientific challenges. His group focuses on the acoustic monitoring of natural environments, in developing cutting-edge real-time sensing systems and AI tools to extract ecological insights at scale from audio data. We've invited Sarah because of this extensive experience in managing large-scale ecoacoustic monitoring networks, and today he will talk about soundscape analysis for biodiversity monitoring, exploring acoustic indices, current limitations, and future directions in the field. I'm very much looking forward to this talk because I think it's one of those ones that's got a lot of conversation and controversy around at the moment. So I'm interested to hear what you say. So take it away.
Great. Thanks, Stephanie. Yeah, I guess my talk is going to be a bit more specific than the last couple, which have taken a really good overview of the field. And what I'm going to talk about is like kind of my views on soundscape monitoring, informed almost entirely by 3 papers that I'll sort of put up at the end so you can know how they string together. Yeah, and also as Stephanie mentioned, I love the sensors and stuff, so please, yeah, I'm interested in the hardware bit, but today I won't be talking about that. I'll just talk about soundscape monitoring. So I think you're all aware of this probably. I've seen in the sort of chat we're exclusively bioacoustic people in some way. But there's 2 approaches to analyzing ecoacoustic data. One is what Stefan talked about, species ID, BirdNet. You can tell whether a bird is here or there. You get occupancy data, maybe abundance if you do some special localization kind of stuff. And these are brilliant ecologically relevant outputs. Ecologists know what to do with species occurrence data or species abundance data, but building the models are difficult, testament to sort of what Stefan and his team have taken on. They've done amazing, but they're still huge. There's 99, I think I was giving some teaching the other day and I was like, BirdNet's incredible, the amount of species that do, but what about the other 99.7% of the species out there, that probably vocalize? And then the other approach is to look at soundscape features. So very basically like volume of an audio clip, look at the site 1, look at site 2 at the same time. Is the volume louder? Is the activity at a certain frequency band louder? Or even we can use CNN-derived features, use machine learning models to extract features. But it's the same idea. You're just getting these summary statistics of an audio file, and you're looking at how these vary across two areas or 2 files at different times a day. These are really easy to deploy at scale, but they don't really have such clear ecological interpretation. One thing we know and have known from sort of Jerome Suar's really pioneering work in this area for a long time is that soundscapes can predict ecosystem quality, and that was kind of the initial reason people started using these soundscape approaches. So here I've got 2 examples that I've shown from a paper of ours where we're predicting avian richness. So we had point counts data and we had audio recordings during the same point counts. And so someone on the floor was writing down, I've seen this bird, I've seen that, and we got species richness. In temperate forest, this was actually on in Cornell's Ithaca campus. And then on the right-hand side in a tropical forest, we have proxy measures for habitat intactness, above ground biomass. And we used both soundscape indices, the traditional entropy type ones in blue, and CNN features to predict these different metrics of habitat quality or biodiversity quality. And, they both work. The soundscape indices don't work quite so well, but they're still far, far better than chance, right? You're getting good classification accuracy from both. You're getting probably better performance, quite a lot better performance if you use machine learning embeddings. But okay, great. Soundscapes can predict ecosystem quality. That much is kind of agreed and has been agreed across the literature. Another interesting result from a paper we had in 2021 was that soundscapes can predict species occurrence. So here what we did, what you're looking at here is on the y-axis are different sites across a degraded tropical forest landscape. So at the bottom you've got old growth, and then at the top you've got oil palm, and then there's selectively logged and logged forest in between. And so you're kind of looking at a gradient of habitat quality on the y-axis and then hours a day on the x-axis. And in red, we know for sure whether each of these species, the yellow-vented bulbul, the sooty cat babbler, or the treehole frog, were found at these sites at these times. And in blue, we have soundscape predictions using machine learning models on soundscapes of whether that species would be there or not. So this is subtly different to species ID, right? But it's getting at the same idea. It's using the soundscape as an indicator of whether the species will be there, but not necessarily listening for the actual vocalization of the species. So you can detect non-vocal species this way, insects, and when we looked in actually at what our model was picking up on, it wasn't learning to identify the vocalization of the yellow-vented bulbul. It was learning to identify general soundscape drivers that were typical of when you find a yellow-vented bulbul. So you can do this for nocturnal, diurnal species. It picks up on variations on the soundscape and gives you an estimate of habitat suitability for each of these species. What was quite nice and validating was that actually this performed better than your traditional ways to do to do habitat suitability. So ACD is above ground carbon density from flown over LiDAR sensors of the same forest. So, you might say, well, why don't you just measure habitat intactness or some habitat quality using LiDAR scans, which we have for everywhere? Well, it doesn't give you quite as much predictive performance. And that's a useful sort of 0.1 increase in AUC. So it's meaningful, and you can pick up on areas that might seem like they have suitable habitat for a species, but actually don't this way. So yeah, soundscape to me is to do sort of community level things, but also species level things. But a big question that's kind of flying around is like, how reliable are these predictions, and how generalizable are these predictions? And so this is a study I'm going to go into a little bit more detail on. And here what we did was we got 4-point count and acoustic data sets. So in the US, Taiwan, India, and Malaysia, we had hundreds and hundreds of point counts, thousands in the US, almost 1,000 in Malaysia. Independent point counts, so someone on the ground was writing down every bird species they saw for a period of time, 10 to 20 minutes, and an audio recording that was made at the same time. So we know exactly the soundscape, and we know exactly the avian species community that was found at each of these locations, and for thousands of replicates. What we found was here we did univariate correlations of the soundscape features with avian species richness. And what we're visualizing here is the number of data sets that acoustic features correlated with avian richness on with. So, all of these in the 0, that means there were about 10 soundscape features which didn't correlate with avian richness in any of the 4 data sets we looked at. And slightly fewer learned features. So learned features being the CNN machine learning derived embeddings. The key takeaway from this is that you're very likely, if you pick a random soundscape feature, to get a correlation with biodiversity in at least a data set if you look at 4 data sets, right? Most features, either learned or soundscape, like sort of entropy-based features, correlated with biodiversity in 1 or 2 data sets. But that kind of implies that for the other 2, there was no correlation. So we're looking here at like 60 different soundscape indices and 128 different learned features. So how do you know a priori out of these, 200 odd features that you can choose which one you choose to measure biodiversity? And it's quite clearly showing there's not really generalizability happening, at least on the univariate kind of approach. We also found that machine learning models didn't generalize. So, the first slide I showed you where I said soundscapes predict habitat quality or something important about ecosystem that we're monitoring. What I was showing you is if I have a training data set from India and an independent test data set from India, I get a fairly good R-squared. I can predict species richness quite well. And the same with Malaysia and the same with Taiwan. But if I train my data using the Taiwan observations and then I test that same soundscape model to predict species richness somewhere else, for example, India, Malaysia, USA, I get almost nothing. And in most cases, this cross generalization, there's no predictive power. So you can do better than this. You can do better than univariate correlations with machine learning algorithms, but you still can't do the generalization. One thing we did find is that soundscape change correlated with community change in each of these data sets. So that's something that you kind of get for free, is if you track a soundscape from point count A, and then you look at the difference in the soundscape to point count B, your species community is going to be quite different from point count A to point count B. But it's not a golden bullet, right? On this graph, you can see there's lots of clustering in this top right corner. And what that shows you are at times when the soundscapes were quite similar, there's low soundscape distance, but the species communities were very different. So massive species community turnover with almost no soundscape difference. So it's not a golden bullet. And, we only looked at avian species here. But that's kind of already showing, if the cluster were the other way, you could say, well, what about all the other species changing? But that we're finding the inverse of what you'd expect by looking at a subset of the community. And I guess the kind of soul searching thing of this graph really, which summarizes this study in a picture, it's like, do we expect soundscape models that are trained in Malaysia to predict species richness to perform when deployed in the USA? And I'd say, no, that's kind of a bit ludicrous to expect the species communities in the USA to sound the same as the ones in Malaysia, and for when they scale in diversity, for the soundscapes to change in the same way. But that is exactly what we're doing in the literature time and time again by publishing more indices with more features and saying, look, this method works, it's better than the last method, go use it in your new study. So yeah, my key takeaway is soundscape approaches are cool, they work, you can predict lots of really interesting stuff with them, especially if you use machine learning approaches combined with the soundscape approach. But this idea of soundscapes, there being some universal hallmarks of biodiverse or high quality, whatever you're measuring, soundscapes is probably a bit of an ill-posed problem from my perspective, at least with this data that we're seeing. And these are the 3 papers, so you might just want to quickly screenshot and jot them down if you're interested. And they kind of follow this story that I've presented to you today. Yeah, thanks. And please, as I said, I've launched my lab only in the last year, so do get in touch if you're looking for new collaborations. We're in a pretty good position to be opening up and engaging with large projects.
Thank you. I won't lie, you kind of went really deep for me as a kind of an expert outsider, but I think you brought it back at the end and summarized it perfectly and gave me 3 things I need to go read now. Okay, let me just check the chat. I want to ask a question that came up last meetup and in the session on data platforms and networks, and they started talking about the use of embeddings to make acoustic data sets from different networks searchable as a future goal. Do you think that's, as I understand it, which might not be correct, embeddings are possibly an improvement on indices? Is that correct?
Yeah. I mean, improvement is
Okay.
if all you're looking for is raw predictive power. Yes, they're more descriptive and you're likely to get better predictions of whatever training task that you're looking for. What you lose in interpretability, right? Someone might have an indice that tells you really clearly something that a biologist can come and say, this tends to work well if you have, say, recordings of one species.
Okay.
And you use an indice and you're like, oh, look, there's more variability, and that might actually tell you something about the vocal species of that one population that are different to the vocal mechanism of that one population compared to the vocal mechanism another. And that's something that machine learning approaches would struggle to do, is tell you sort of insightful things about the actual audio that's being produced and potential mechanistic underpinnings. But if all you're looking for is just to use a soundscape to predict an output variable, a sort of target variable, then embeddings and machine learning approaches are probably a bit better.
Okay. Alma, do you want to ask your question? Do you have a mic?
Yep. I was just thinking that in order to train Soundscape with pristine ecosystems, as we continue to degrade ecosystems, how do we go about finding somehow a baseline for what a pristine ecosystem is, so that you can have that comparison? And how would you think about, or how are you overcoming the problem that we perhaps will never know what pristine ecosystem is?
Yeah, that's a really good point. There's a lot of talk, and I'm sure it's come up in different sessions, about this kind of deluge of data problem in bioacoustics. And people are saying, which data do I need to keep? Should I just delete it? And, that my first comment is, don't delete any data that you've collected. The value of an audio recording, especially as you say, if you got it from pristine ecosystems which are being threatened, if storing your data is too expensive, you're probably just not doing it in the most efficient way. These days, the amount of data that a small startup could hold in, measured in petabytes and beyond, is incredible, and the cost efficiency you can do that. So I think number one is finding ways to make sure all the data that people have already collected is archived safely and for a long time. And so how to collect more data, yeah, it's just, a question of funding, I guess. I don't think there's another way around it, and sort of the importance of, but I guess it's also, why do you want that pristine ecosystem comparison? It depends what your question is. And if you've got the right question, you should be able to justify collecting data from those places. Yeah, it's difficult for sure.
Abram, do you want to ask your question?
Sure. So in my head, like Soundscape indices are this tool to kind of a low power, low cost tool to try to correlate with various ecological processes. If you had a model that could detect every species, like if we break through this ability of not being able to process these data sets and actually do this species detection, like, do we think that Soundscape indices still have like a place in our research toolkit?
Yeah, that's a really interesting question. And, this vision of like perfect sound event detection for everything, right? Not just species, but like anthropophony, geophony. No, I don't think you do need Soundscape models at the end, right? Because what you can do is you can go back and recreate those indices from the fundamental knowledge. How likely we are to reach that in, decades. And to be honest, at a point where most sites, when we're going into tropical forests especially, we like ecologists, taxonomists don't even know what the species are, let alone having the training sets to train a model and stuff. So yeah, I agree that in a perfect world, we don't need it. I would add the one caveat that there is this really interesting field of perceptual soundscapes, right? Like, as a human, how does this soundscape influence me or my enjoyment of this environment or my engagement with nature in this setting? And there, I think these summary statistics of how the soundscape comes together as a whole are actually more directly to the point of what you're trying to measure. You're conserving the soundscape as an emergent property rather than the species underlying it. And there, I think that there's an interesting route for soundscapes that it stands alone from species detection.
Okay, interesting. Okay, thank you so much, Sarab.